of Community. Jim Wilson from Delphi is with us today. Please ask questions during the class by typing them into the questions area on your control panel. Jim is going to answer all your questions after the class ends. Now let's get going. Jim, it's all yours.
Good afternoon to every one of you. Getting the most from a digital multimeter, that's an interesting subject because we need to be able to use the tools we have. I wanted to make sure that everybody understands that that's a second tool in your diagnostic toolbox. Before you replace the sensor, you should be checking the voltage to it. You should be checking the ground. You should be checking the what comes out of that particular sensor. That way it gives you a little bit better information on what's going on. We're going to be talking about choosing a digital multimeter, and I'm going to lean toward a little bit more expensive sides, but there's a reason for that. We're going to check the accuracy of your digital multimeter, and we're going to do some diagnostics, some voltage drop testing. I have called the 3-point circuit test on sensors. So you usually take the farthest 3-wire sensor from the computer you get, and that's the one you use to check the grounds, the power, and the whole circuit. It gives you a lot more information. We need to be able to check duty cycle, frequency, min-max, and peak min-max. That's what we're going to be looking at. I'm going to bring this right off the bat. If I have a fixed value of my voltmeter, it's going to average the reading. If it averages a reading at 2.5 volts, I can assume that that is correct, but I might want to put it in duty cycle, seeing that's a pulse signal, or I might want to put it in frequency and check it. I might want to do a min-max. If I do a peak min-max and it's a 2.5 volt sensor output, but it's a 5 volt sensor, I would get the 5 volts and the ground. There's a lot of good information up there. We need to be able to check the power, the grounds, and do a little bit of bus testing with your meter. Big thing about it is your grounds are going to be always an issue. They always have been. They always will be an issue on particular cars. So some top essential functions to look for in your digital multimeter. Auto off. That means it's going to shut down and keep the batteries from running down. That means when you quit using it, it automatically turns off on its own, so it's ready for the next time you use it. You need to have some auto ranging capability. If you have auto ranging, it will actually move the meter to get the reading in range of what it's looking at. It reduces your time for setting up a new circuits. I always use auto range because it's easier. Then I might go down in a particular circuit if I need to. Min-max and average helps with the intermittent problems. If you have a intermittent problem, I might want to shake the wires and see if there's a min-max and average on it. There's a hold button. That's going to freeze the screen reading. So if you've got one that's kind of flaky on you, different, just hit the hold button and grab it when you can and get it and look at it and relate it to what you're looking at. There's an auto hold mode button, which captures the present reading. Then it beeps with a new stable reading and it displays it. So here, if you think you've got a problem with the circuit and it's messing you up, you can actually walk away. When the beep kicks in, you can come back and see what the reading, if it changed. Frequency and duty cycle for pulse and DC square waves and AC sine waves. You need to have a fuse for the high amp and low amp meter, high amp meter and low amp meter in the setup. That's meter protection, basically, high and low amp meter current readings. You have to have an analog bar graph, if at all possible. Not all meters have that. Analog bar graph is that little bar graph you're going to see at the bottom. That updates 40 times a second on a Fluke, I know for a fact. The screen updates in the meter readings is going to update 4 times a second. So which one would be more accurate and give you tendency to look at readings if you're going across? The bar graph is a really neat thing if you're sweeping a TPS sensor and you want to make sure it's working properly. When you slowly open it up, the bar graph should slowly increase and come back down. If you ever see it little jiggle on it and grab up, you probably got a glitch in your TPS sensor. We need to be able to do a diode test, forward basing diode. We need to check our diodes with their meter, make sure it's working properly. It's going to put out somewhere between 6 to 7 volts on there and turn it on. If I use my diode test, I also can trigger a transistor with that. So if I have a circuit that is transistor, turn it on, I can use my meter for that. Category 3 or 4 volt or higher for hybrids, that's your leads and a whole bit. You want to make sure you have that one. Eventually, you're going to probably have to buy another meter just to do hybrids, kicking up there a little higher dollar meter. You want to do a true RMS rated meter for better AC readings, and we'll show you that in a graphic in a little bit. You might need more than one multimeter. Here I am. I'm telling everybody when I'm doing scan tool classes, you're going to probably need more than one scan tool because not all scan tools do the same function. Well, let's go look at this real quickly. I got a digital multimeter on the left-hand side, and that's your 87.5, which is a good fluke meter. It's showing me frequency, and it's an AC. All right, that's really good. The one in the middle is what's called a clamp-on multimeter. It has an ammeter built into it that is really sensitive to milliamps. The Midtronics, ESI, a few other companies make these meters that are real sensitive. The other idea is they have a big enough opening so you can get around the battery cables and do your parasitic draw a little bit easier with that particular meter. Some of you probably remember the old Vantage meter. That was a graphing multimeter. The old Perception was a graphing multimeter from OTC. Well, one of my scopes has the graphing multimeter function. Actually, two of them do. I have a Bosch 5200 and I have a UEI scope. That's one right there. And it will actually be able to graph over a period of time, 5, 10, you can seconds if we want to, or longer. And it will be there and it will show you if you have a problem. So if I'm looking at this meter, I got a glitch capture or parasitic draw. We're going to look at two different things here real quickly. Those two extra meters you might want to buy. So right now it is at 3.827 hertz. The maximum was 4.96 hertz. That's what it was. Every once in a while it glitches to a lower reading. What I'm using is the Snap-on little tool for, it's got the interface. You can put signals out, and this one would show that we had a little problem here. But go to the right-hand side, I have my clamp-on meter, current draw for DMM with good readings. So anything under 50 millivolts after the computer goes to sleep tells you you're looking good. If I'm above 50 milliamps, I know I have probably a parasitic draw somewhere on the particular vehicle. So when that happens, then I have to do my diagnosis a little bit differently. A lot of us remember the old little cable ends we had where you would pull off the cable, you put this little adapter in and turn it in and out and do this stuff. That is too much like work, number one. Number two, it messes you up when you're doing your testing. So here's the deal. If you're working on European cars, Audi, Volkswagen, BMW, and Mercedes all started doing what they call quintessenic, I think is the way you pronounce it. I can't pronounce every word in the world. And this is courtesy of Mercedes-Benz Star 2 magazine. You can see they're telling you how to do this, and they're showing you how to do a parasitic draw by using the voltage drop across the fuse. Now, the other thing I want you to do while you're here, I'm going to put you to work a little bit. I want you to go out and Google BMW ST1102 Advanced Vehicle Diagnostics. That's a manual. When you go over and do that, it has about 20 to 30 pages of how to use your manual and what is a good how to use your multimeter, excuse me. The manual will tell you to use your multimeter, 20 to 30 pages there of telling you how to use your meter for doing circuits. At the end of it, it will actually go up and tell you how to do this parasitic draw testing by using a multimeter. If you were using Ohm's law to calculate this, you would see the parasitic draw across this. You would see the voltage. You would have to know the resistance of the fuse, and fuses do have resistance. You would divide the resistance of the fuse into the voltage, and you would get the milliamp draw going across. That's too much like work. So what we have done over a period of time, they have gone out and measured the resistance of the fuses pretty much going across the standard. And what they've done is they've come out with a parasitic draw test up here. Yes, you can use your temperature gun if you guys are out there, but you're still going to have to measure the draw somewhere down the line. And if you measure the draw up here, let's say I go up to the top one, I got 0.1 millivolts. 0.1 millivolts. That's not much. And on a 30 amp fuse is going to be 0.062 amps. 25 amp fuse is going to be 0.46. So you're looking at the circuits, and we're looking at this process, guys. What we need to look at up here, it says 0.62 and it goes across. Each fuse is going to be slightly different. So do not assume they're going to be the same. The larger the fuse, the more amperage draw is going to be going across, is going to give you a parasitic drain test. So that gives you a good idea of what you're looking at when you're going across. Power Probe has a little chart like this. You can go out on the internet and just Google this, and there'll be all kinds of charts. You want to start using this because anytime you remove a fuse, you will normally activate that computer. If you activate that computer, that means your readings will go off. So you need to be able to check this. So again, don't pull fuses. Use your clamp-on meter to begin with, and then go do your parasitic draw by doing voltage drops across the fuses. If you're a European tech, you've been doing this for years, or I hope so anyway. All right, do you know the default readings for your multimeter? Just a question for you. How many guys' meters default to manual? How many of them default to auto? You have to know that if your meter, because sometimes you want to do it. So if I'm looking at this 2 meters up here, we look at the 87, it's in auto. The 88 is in manual. Kind of interesting that those 2 meters are working slightly different than we would normally expect. So we're going to watch a little video here and watch what happens. Watch the bar graph. It's barely usable on the 88. Doesn't work, but 87 works really good. So what I'm going to do is turn the meter off, push my button on the high resolution or the light button up there, flip my meter up, and notice it went to auto. Went to auto, both the meters are going to read the same. Now my bar graph is better. It's working exactly like this. So if I'm using auto, it will make my bar graph work that much better. Now keep that in mind. Now, somebody just recently asked me what the high resolution, where it says high resolution, you push it down for 1 second. You push it down for 1 second, and where it says 0.0821, it would now go point. The decimal point would be before it. So now instead of 3.5 points on the meter, it would go 4.5 points and activate the system a little bit quicker. It's give it about 10 times the better resolution. So again, if you're using your meter, you push it down 1 second and it will flip it over if you have that on your tool. All right. Let's do this one. We're going to test our meter. Sometimes you're going to buy a meter or somebody's going to buy a meter. They're going to buy from some store that we don't know if the meter is that good or not. I've actually had people buy meters and bring them into class. Electrical classes are not as good as they should be. Your meter needs to be 10 mega ohms impedance. The reason we need that is the high resistance of the meter. Your meter is going to flow voltage through the meter. If it's higher resistance in the meter, that means it will not pull that much voltage from the circuit it's working on. If I have 1 mega ohm, it will pull voltage from the circuit and affect my readings. It will actually affect the circuit. So what I want you to look at is, watch this. I'm going to take the 88. I'm going to hook just these 2 meters to each other. You can do it when you get a chance. I'm going to turn 1 meter to ohms. Notice I went F88. The other meter, you notice I'm reading 11.10. So the 87 has 11 mega ohms, and it put out, in ohms, it put out 2 point something volts. Notice that the 88 is 10 mega ohms impedance, and it puts out 2.67 volts when it's in ohms test. That immediately tells you I am not going to stress the circuit by putting out 2.67 volts. So that's why when you're doing resistance testing, you're always better to do a voltage drop testing. The only time I do resistance testing is when I have a spec for resistance. So they're showing you some really interesting stuff that you can use. The next one, checking fuses. Depending on your meter, I'm using the Fluke 87 and 88 because that's what BMW uses, that's what Volkswagen uses, that's what Ford uses. 87s use the General Motors. They are setting all their specs up for a particular meter. So there are times I will use my 87. There are times when I use my 88 because 88 is more of an automotive meter, 87 is more of an industrial meter. So it says good F2 fuse. It should be on the sides over there, 0.00 ohms to 0.5 ohms. That's checking that fuse. All right, that's the high fuse. All right. If I check my other fuse, it's on the milliamp fuse, it should be 0.995 kilo ohms to 1.05 kilo ohms. So let's check this meter, see if it's okay. One lead, and I'm using a 4 millimeter banana type plug on the end there instead of the other one. If I was using the other style, I'd have to pull it up and touch. Notice there's a lead and it says 0.1. I am within range. It is good fuse. And I do this one lead. It says 0.99, 0.98. That means I'm in range. That fuse is good. So I know immediately I can check amperage without giving me false readings. So it had to be 0.995 to 1.05. Both of the specs are good. Got good fuses in the system. Read the manual on how to check the fuses. This will save you a lot of trouble because sometimes you check in a circuit and the fuse is bad, especially if you lend your meter to somebody else. All right. Let's do one other thing. You want to check your leads for resistance. And I will tell you automatically, you're probably going to buy more than one set of leads. The standard leads that come with a lot of these meters are no good. Let me get rid of that one. I forgot to turn that off. A lot of the meters that you're going to look at, the leads are not the best. A lot of times you want to replace them. I'm using better leads. You just find the leads and check them. So what we're going to do is we're going to check the leads and we're going to zero it. The reason I want you to do that is this. You want to make sure if you're doing resistance on the leads. So let's go ahead and do that test up here. Put your leads, jumper them together, put in ohms, and it says 0.2, 0.1, somewhere in there. It's probably 1.5. If I hit the REL button or the 0 button on your meter, some of the meters use, some different brand meters use 0. Watch what happens. Now I'm at 0.0. All right. So right now I have not erased the resistance on my leads. What I've done is taken that out of my reading from my meter. So what it does, it erased the 0.2 or the 1.5, whatever it was. It erased it from the readings, but it's in memory somewhere. So that means is if you're having problems with the circuit and you're not getting quite the readings you want, you should have already zeroed your leads. Now, if your leads are within 0.1 to 0.2, your leads are good. If by some chance your leads are reading 0.3, 0.4 or more, the leads need to be replaced. And you should do this on a regular basis, especially when you start using your meter in a process. It'll save you time. We had a meter in a class recently, and just some guy was bringing this up for me a little after the first class, and his meter read 1 volt. I mean, 100 millivolt, 100 milli, I'll get it right yet, 100 ohms. That means that he would have affected my circuit and had a problem. So we checked that one out. Again, 0.1, 0.2, okay, 0. Anything above 0.2, the leads need to be replaced. The other thing you need to do is make sure the leads are connected together well and the leads are pushed into the sockets correctly. Because I've seen sometimes the guys get one where I'm not getting, Jim is really bad because they haven't pushed the leads in correctly. All right, let's talk about 3 steps of circuit testing. This is just my way of doing it. I call it the natural point break of a circuit. The natural point break of any circuit is before the load and after the load. If there's 2 loads, before the first load and after the second load, whatever. So you should check the supply voltage to the circuit. Well, right now I know it's a battery, it's got a fuse. I should have battery voltage at the load. Keep this in mind. You use up voltage in the circuit. Amperage stays the same throughout the circuit. So keep that in mind when you're doing this testing. So at the top there, I have a fuse. Well, it should be what? Battery voltage. And if I go before my load, right before my load, find the easiest place in your wiring diagram that you can do this. I go before my load, it should read what? It should read battery voltage. What if it read, you know, I should have battery voltage. And what if it read 12 volts? Then I drop 0.6 volts across the circuit. I have a resistance, a drop there. That can be from corrosion, bad connection. That can be other things. So I would want to back from the load, work my way backwards to find it out. When I find out source voltage, but I didn't have source voltage on the other end of that one. next step up there, that would be my issue. So I would go back from after my switch, before my switch. If all of a sudden I had source voltage at my switch on the feed side, but on my switch on the side feeding over after my switch, and I had a drop in voltage at that point, I know my switch is my component I would need to replace. And the easy way to do is jumper around that with jumper wires and doing the process. If on my load, let's do this real quickly. If on my load, after my load, I should read less than 100 millivolts on a 12-volt circuit, less than 50 millivolts on a 5-volt circuit, or less than 70 according to Ford. But if I read, I just recently had this problem where I had a fuel pump that needed to be replaced. They had to replace the fuel pump 3 times, and they were telling me they're going to put it again. Happened to be another instructor I worked with. And what I ended up doing was I got underneath the vehicle and I checked the power feed to the fuel pump was adequate, his battery voltage. Then I checked ground wire on the fuel pump and it read 4 volts. Well, 4 volts indicates I have a what? I have high resistance on the ground. So I went back, cleaned the ground, put it back together. And we didn't need that other fuel pump because it was a bad ground. I've seen times where you will have problems with vehicles where they won't start, and an issue where somebody put an engine in it, forgot to put the ground cables back in. So there's some other issues we need to look at. There are 2 ways to check voltage: working or open circuit voltage. This is an open circuit voltage. This happens to be project car at the house. Why I got this one, I have not ever figured out, but it runs good. I got 11.80 volts. This car's been sitting up for days, so I got 11.80 volts, which indicate my battery is somewhere between 40 to 30% according to the chart. I would normally, on this particular vehicle, have to charge the battery to get it up. Well, I didn't do that. What I did next is this. I actually cranked it over. I put my meter in min-max. Now, the reason we're using min-max is you can't always see what's going on unless you put that meter up there, and sometimes you miss it. So the good idea is to put it in min-max and record the information. Let this meter do its work for you and take a little bit of effort out. A lot of you work by yourself. I tend to work by myself up there, so I'm going to use whatever tool is available to do my diagnostics better. So 9.82 volts, I need 9.6 or something up there, so my system, my battery is good. It's just it was low in voltage because it was sitting up for a few days. I knew this, but if it was 11.80 volts after the vehicle came in, or they shut it off, brought it in, I would automatically charge the battery up first before I did this test. Now, the other thing is, I put it in min-max and went to the max on this one. I read 13.88. What do I know here? The charging system is working because I got 13.88 volts. I know it's doing a job. I think we have 14 at one time, on another time I did this, but whatever the charging voltage. The next one is average. So I use my meter's power to save me some diagnostic time, because what did I do with it? I cranked it over, put it in min-max, and recorded my information. Some of your scan tools are starting to do this. So if your scan tool will do it for you, that's great, but that's interpreted data. This is actual data from that. Your scan tool is interpreting data, so it has to come up and read it. So this works out really good. If you have AC voltage, I learned a different way than most of us have been doing this. I have 1.6 volts AC up there. Notice my bar graph is there. I'm in auto mode and it's at 6 volts. So let's bring this up right now. Older meters used to go 440, 400, and 4,000. The new meters are going to go like this. They're going to go 6 volts, 60 volts, 600 volts, and 1,000 volts. The reason they switched over to the 6 is most of our sensors are at 5 volts. So what happens is on this particular meter or another meter, if I went above 5 volts, it would automatically go all the way back to 0 again and start over as it went up, because that's what it would do with the range. By going to 6 volts, I don't have to do that. That's why the newer meters are better for this type of work. There's my crazy face in that one. The other thing about it is, this is my older DAT meter up here. And I just pulled it out and reread the manual on it, had some fun with it, but I pulled it out just for a specific reason. When you're checking in an AC circuit, a lot of times on your wiring diagram or even the sensor itself, it will say a plus or it will say high and it'll say low or a plus and minus on it. So you put your black lead on the low side or the negative lead, your red lead on the positive side. The only reason I'm telling you to do that is you need to learn to put your meter leads in the right position. A lot of you will see negative voltage over a period of time. That means that you didn't put your leads in the correct position. Will it make a big difference on this one? Not really. But if you learn to put your leads where they should be, you're going to get better readings on the particular vehicle. So again, I want to hook on both sides of this lead, of this sensor. The main reason is I get a more accurate reading instead of just plugging one side or the other. I want to make sure I get the proper AC reading when I'm doing my testing on it. And you need to be above about 30 RPM before you actually get a stable reading. The reason being, I'm telling you, use an RMS. Notice it says true RMS meter up here on 87. If I have the meter reading on the left-hand side, I went out and duplicated this meter reading. I went out and used all my different meters. Every single one of them came up with the exact same voltage on that one because that's a uniform pattern. There is no deviation in it. It looks normal. The one on the right-hand side shows you how we really get some of our crankshaft sensor readings on it, or some of the other readings. It's not a true sine wave. And if it's not a true sine wave, the only way you're really going to get the information you need is to have an RMS meter to get the actual reading. So it has an algorithm, and what it goes through mathematically equivalates what it should be. Equivalate's a new word, by the way. It gives you the readings you need. So again, that's why you need an RMS meter. Okay, when we're doing ohms testing, resistance testing, you must isolate one lead from the circuit to test. All right. So what you're going to do up here is you're going to have to pull one lead off. When I'm working on a computer circuits, I have to unsolder a lead sometimes to check a resistor. So if you see my red leads on one side of, that's a light bulb there, and my black leads on the other. So I'm reading 16.7 ohms. All right. So I'm checking that because I'm not in the circuit. I had a guy at a class I was doing recently. He had 5 mega ohms on a circuit. Well, the reason he had 5 mega ohms on a circuit because the computer was still in that circuit. You always want to pull one leg out. We're doing voltage testing in parallel. We're doing ohms testing in parallel. We always do current in series. It makes a big difference. Now, while I'm here real quickly, some of you are going to check a circuit and you're going to check a circuit to see the resistance on it. You might check a wire or whatever. If you hit the little button that looks like a voltage sign on, let me do this. I didn't do the with the guys this morning, but I will do it with you here. If you look at the one that looks like it's got a nice little, like a symbol for voltage or sound up there, if you hit that button, it puts a continuity test in. When you put a continuity test, as long as you have continuity, it will beep at you. If you're shaking leads and all of a sudden the beep goes away, that means you have an open in that circuit somewhere. You have to find that. So that's something else to keep in mind while you're doing diagnostics. Continuity test, it's annoying all time if you're using that beeper, but hey, it does help. Current, notice I have to take the leads out and I have to put my leads in place. So if you look at real carefully what I've done on this particular one over here, I took my red lead out, I took my black lead and back probe at this point. So I am checking the current going across this circuit as it's feeding over to my light bulb and going across. You can't see it's there, but it's there. And I'm at 0.077 DC amperage, so I'm looking at it. Again, I have to break into the circuit with a current probe. And you want to do whatever I could do after the switch and after. By the way, let's do this continuity test we were talking about. If I hook from here to here with my meter and I'm in ohms, I can measure the ohms on it. If I put it in continuity test, when the switch is open, it would not have a sound. When the switch is closed, you would have a sound. Something to keep in mind going across. Use a low current probe. It's a great idea to use a low current probe. The only problem I run into is, like I was telling you before, if you're on batteries, those things don't go around as well. 0 to 60 amps, usually what we got on those, and you're going to measure a circuit. So on this one was an injector, as I remember. Yeah, it was an injector circuit I hooked up there and it was measuring 22.2. I think that's what it was. It might have been something else, but anyway, it's reading what's going across in resistance. and we're measuring the current flowing in that circuit. And if you look at it, using a current probe. Why do I have to use millivolts? Because it doesn't relate. I have to use millivolts to know what this is. So I'm going to put it in millivolts because you'll have a little chart in your meter. We'll say 1 millivolt equals this much amperage, or 2 millivolts or 100 millivolts equal this. So you have to watch your meter, how it works. Make sure you read the front of it. Usually always tells you. Testing diodes. On the left-hand side, I have a diode that says out of luck. Ouch, one of my meters read. It's out of limits, and what it means, I always say out of luck, but it's out of limits. It means that it's open. I cannot read, not open. It just means I cannot read it there. And your diode has one long leg and one short leg, or lead, or whatever you want to call it, arm, whatever. So if you put it this way, where I put my black on my long one and my red on the short one, this diode will not flow voltage. The main reason, it acts just like a transistor does. You have to put voltage on the base to make it work. Well, that's kind of what you're doing here. So I have no continuity. It doesn't work. My diode don't work at all. So if I go over and do this, I switch the leads, you notice the light's off, the LED's on, and notice that's a voltage drop across that. So I'm actually putting out 6 to 7 volts up here, depending on my meter, as I do that to turn the diode on. So there's sometimes when you might have to turn a transistor on. You always use the diode test. You don't use ohms. Ohms put out what? It only put out 2.5. So I'm voltage dropping 2.5 on this one, so it wouldn't do a good enough job on the process. And what I would tell you guys also, if you're looking at the class right now, there's voltage drop. So if I'm doing voltage drop, up here, I have a bulb up there, you see it. So I'm dropping 12 volts on that one. So if we're looking at the circuit, if I put my black lead on ground and my red lead on the 12 volt source up there, I would measure the voltage drop across the whole circuit. But sometimes you want to measure the voltage drop on each individual components. So if I was before my switch there and it's on, and after my switch, so you put your red lead on the most positive side, the black lead on the most negative side. If I put it before my switch and after my switch, I would measure the voltage drop across my switch. So you can break your circuit down, each component, by doing it before and after to find out the proper voltages, drop across it. So that's something to keep in mind. Voltage drop is your friend. Voltage drop will give you more information than ohms testing will ever give you. So keep this in mind. So here's the deal. One other thing to keep in mind. I got 12 volts going across that bulb up there. That will change. If we were measuring resistance on that bulb, will change depending on if it's on or off and resistance of the bulb. So I'm going to bring this up. If the bulb is dim, but it's used up all the voltage, what does that mean to you? That means that somebody probably put the wrong bulb into that circuit. If you put the wrong bulb into that circuit, which some do-it-yourselfers will do, they'll come in and they say the light's dim on one side. What you have to know is if the light is working properly, it will be bright, usually be bright on this unless there's a variation in voltage. If I have a dim one, that means the resistance is higher. So again, the voltage drop would be the same, but the bulb will not be as bright. It would indicate you have a load problem that you need to correct. The other thing is if I have across that, if I have 0 volts across that, I mean, that would be what, guys? It would be an open. We have some other things we need to look at. Here's the suggested allowed voltage drops across, all right? 12 volts, maximum allowable voltage drops is 0 across the connection. Sometimes it's a little more than that. 0.2 across a wire cable. Like I'm doing battery testing, I'm allowed 0.2 on a battery cable. 0.3 across the switch. So that switch should have been less than 30 millivolts up there, or 300 millivolts, excuse me, 0.3. And antenna on the ground on a 12 volt circuit. On a 5 volt circuit, it's going to be less than 50 millivolts. Again, unless it's what? About 70. So I'm bringing this one up here. there are times that you're going to run into that you might want to check the lead. I might want to attach my lead this way. If I look at this one, I might want to check my post to my side to make sure I have no resistance between my battery connector, my battery, and the battery post. I just did one, like I said, I had 6 volts on one of them the other day, and it was somewhere down the line they had an issue up here. So that you had an issue of the situation. So what I'm going to ask you guys to do is get used to doing this particular setup, is check this. Now, the other thing we can do, got a little problem there, guys. The other thing we can do is check between the post and the connection or the grommet, and you might want to check from the bolt to the chassis. You're checking the system to make sure that everything is working properly. If you have a bad ground here, this would indicate, most people don't check this, so what you would have to do is make sure that everything's working properly. Now, another thing you can do in this particular process on chassis, and there's sometimes, if this is real important to do, if you are actually going out and doing some diagnostics on it, the big important thing to do is make sure that if the engine has been replaced, that they put everything back on. I have seen sometimes where I've had a 6-volt voltage drop I couldn't even start the vehicle. It had a particular setup I had. And again, you're looking engine block. The problem about it is I ran a cable from the engine block over to the negative battery cable, and all of a sudden I could start the car. Couldn't figure out what was going on. The reason being is exactly this, is somebody forgot to put the cable from the chassis to the engine. It wasn't there, so I had a 6-volt drop. To get this vehicle to start, what they do is hit it with ether. It was a spider injection vehicle. What I saw was 47 when I tried to it. I could put my foot on the brake, it would die. So what they had put 3 fuel pumps, so they thought that was it. All it was is we replaced a cable to the chassis and to the negative post to make sure the vehicle could run properly. All right, so I wanted to bring this tool aid up here. This is from Tool Aid, is a 21200. I just recently bought one because I got tired of having to try to stand there and have somebody else ask. Nobody likes helping me. Well, one man shop, that makes sense, doesn't it? So Tool Aid has a tool, the 21200. What the tool does is it measures the voltage drop. So it has a little probe there, a spring loaded, to go to the battery post. And if you look at it, I can actually take my one lead, hook up the battery post, my other lead to the connection to my battery cable, or I can put it to the chassis, I can put it to the body, wherever I need to do, and I can measure voltage drop between the components. This tool will save you a lot of time, especially if you work by yourself. And since I do that a lot, it's there. This is spring loaded to make tension. And notice I just clamp it around the cable and get a good idea of what's going on. All right. So if we're doing this, here I go again, messing things up. So we're doing this process. Again, that's 21200 from Tool Aid. Thermistor, a lot of your voltmeters have the ability to do thermistor testing on it. This is an advantage sometimes because let's say you have one, all of a sudden you lose one of your thermistors or your thermometers. You can use your meter, put it in the vents and measure the outlet air up there. I have a car that I looked at yesterday that one vent is different than the one in the center. The main reason is I have a ductwork problem on my older car, and I'm going to have to readjust the system to tune it down to get a better reading. I'm going to have to pull the vents and the doors to get it work properly. You also should be able to go out in front of the car, measure the temperature, and measure the temperature at what? Measure the temperature inside. You should see a 30-degree difference if possible. That means you can use your meter also as a tool to check your AC work. It does work, guys. I use it all the time. The other thing is you might want to use your thermistor probe up there before and after components. There's a voltage drop on the AC system to make sure you're checking it properly. There's that auto hold button. I got a 12.9 millisecond reading on here. I held it So I will not get a stable, another reading on this unless I hook this back up and get a stable reading. Again, it holds it for me to see, gives me a reference to look at. Now, one other thing you might want to do with your meter is you want to check the solenoid amperage draw. So I'm hooked up between the switch and this little solenoid I got in the middle. This is the board because I can't go out in the car, do it as easy, but it's here. So I just gonna go up and look at this, turn the switch on. You see the solenoid move and you see the amperage draw, all right? 0.282 DC amperage, not much up there, but that solenoid up there. So I can actually check the solenoid and make sure the amperage draw. Now, if I could calculate that, if it's a solenoid, I could calculate, if I know the resistance, I could calculate what the amperage should be, all right? So we're looking at that as in process. So now I'm also can check the applied voltage. You can't hear this, but it's a nice little click when that thing's going on and off. So I want to make sure I have applied voltage to it, which is battery voltage, and I want to see movement. Why would this be important? Because sometimes we have a loss in voltage to a particular circuit. On this particular circuit up here, I might have a loss to it. I know if I have adequate voltage being delivered to the solenoid. Let's say I had 10 volts to the solenoid. It might not work, or it might not work properly. So I want to make sure I have the proper applied voltage to it, the proper amperage to it, and you can do that with your meter. Okay, we're going to do some generic testing on O2 sensors, and I recommend you do this. I recommend you do this on any time you have a field trim issue. Always check the O2 sensor, see if it's reading properly. So this is, I kind of modified this for something. You don't have to pay attention to all the steps, but here's the deal. Get the engine operating temperature. You probably remember Ford and some of the European cars wanted you to run the engine at 2,000 RPM to make sure it's the O2 sensor's up and hot and running. That used to be because we used to have the single wire O2 sensor, but the process is still the same. So run the engine operating temperature, turn it off, back probe, gives you a T-pin back probe with some from AES Wave or whatever your system does, and attach your red voltmeter leader to the sensor signal wire. You might have to look that up. A lot of the vehicles right now, it's going to be black. Take your black lead to a good ground connection. You should always check that ground connection beforehand. So you always check the battery, make sure you put the good connection, then check it at the battery and make sure you're reading proper voltage. Run about 2,500 RPM at 2,000, it's okay. Get out your propane enrichment device. I have one I've used for OTC for years. They used to be like 50 bucks. Now they're 150 bucks, but they're there. Artificially enriching the mixture by directing propane to the intake manifold and the RPM drops about 200 RPM because you're loading the system down. When you do that, the voltmeter should rapidly increase to 0.9 volts or higher, indicating the system's got a rich fuel mixture. If you've got your scan tool up there, you'll see it's trying to take away fuel. All right, but it can't because you're making it artificially rich. Next one. Shut the propane tube off, pull it away, and create a vacuum leak. What I tend to do is find a good source point up there, and I apply propane to it, yank the hose off, and that creates a vacuum leak. The voltmeter should rapidly indicate 0.2 volts or below, indicating the sensor's lean mixture performance. It means it can read. If it can't go below 2, we got an issue. That messes up my fuel trim. Next one, plug that vacuum source off, run the engine at 1,500 2,000 RPM again, and check for the average voltage of the O2 sensor. It should be somewhere between 450 to 500 millivolts on most cars. On Chrysler products, on the one that reads, the sensor on that one is going to read 3 volts because their sensors read 2.5 to 3.5 volts. They are not an air-fuel ratio sensor like everybody's been telling me lately. They are biased to ground by 2.5 volts. So the average should be 3. Some of the European cars, you'll find out they will bias the ground on older Europeans by 300 millivolts. Some of the Audis, some of the 5.9 systems, the Bosch 5.9 system will do that. They'll bias the ground by 300 millivolts or so. So they shift it up. So watch your readings on there. Next point is a key point. What is the average O2 sensor reading? Not all scan tools give you that reading. That's why you have to actually do it yourself. So I know for a fact, I think Snap-on does. They graph and give you a min and max reading. I know the OTC and Bosch tools do, but you have to use the bar graph, not the line graph. Well, I like using the line graph. I have to flip over the bar graph to do that. That's something there. Some of my other scan tools do not give me the average. They only give me the high and the low, or whatever it is at that point. So that's a good idea to see if the car is biased. A car can be a bias lean, so the voltage is less than 400 millivolts, bias rich, above 600 millivolts. So you want to make sure that you check this to see if you have a drivability issue on the particular car that's causing a problem. A vacuum leak would be bias low, and they have an indication of that one. Something else to keep in mind. All right, do all scan tools close the canister vent solenoid? And that is not true. Some of the Korean vehicles, I know for a fact that the scan tool they don't give you access to that. They only do it with the factory doing this normal procedure. So what you might want to use your voltmeter. So we're going to do this another way. I've seen other people do this, but I've been doing this for quite a long time. If you have a solenoid, you're going to use your voltmeter. The easiest way to do this, I'm going to show you the way they wrote this. Say disconnect and plug on the evap vent solenoid. Well, you don't necessarily have to do that. If you back probe it, you can see one side is going to have battery voltage to it with a key on. The other side is going to have what? The other side is going to have no voltage on it because it is the ground circuit. Figure out which one's positive, which one's negative, and remember which one it is. Always find a good ground when you're doing this testing. If you disconnected it to do it, reconnect it, rotate the selector to amps position or amperage position, move your leads, the red lead to the amperage position. Now, when the voltmeter is in amp meter testing, it will provide a direct current path to ground with the vent solenoid. So when you back probe the vent solenoid on the ground side and you touch ground, it will activate that solenoid and close that solenoid, allowing you to smoke test the system. Works great. The other thing is anything, by the way, I want to make sure I go back forward here. Only test on solenoids are either on or off, not duty cycle. Not a purge solenoid, the canister vent solenoid. If a transmission had a solenoid, it would be turned on and off. Not duty cycle, but turned on and off. You could do it with that. So if you use the ammeter up there, vent to ground, key on, engine not running, touch the black lead, the negative post of the battery cable, or find a good ground for it. I always try to find a good ground wherever I'm at, and it'll energize the solenoid, closing it. While we're here, there are times that you're going to want to run extra long leads, or as we talked this morning, you might want to have a fast below fuse in the red lead. You might put a fast below fuse in there. When you do that, you have to zero it out. So that's why that REL or zero is there, to zero the resistance, added resistance in the circuit while you're doing it. I got a wiring diagram here, and I'm going to be looking for an injector. Down at the bottom right-hand side. So I blow that up, make it easy. I'm going to be using injector number 5. And injector number 5 has green and yellow is my ground side, black and red is my feed side. Notice interesting, all the feed sides are all black and something. So that's showing you that. Now, if I'm using my OEM wiring diagram, it's going to be different. So you're going to back probe to the ground side of the injector. Some of your voltmeters, like my DAT, will actually tell me I have to back probe both wires. What it does is it acts as a Noid light at that point on the older style injectors. And then when I fire up the car and push it into injection, it will give me what we're going to show you, the peak voltage on the injector and the duties or the millisecond pulse width of the injector. So I've got it. You guys are really good on this wiring diagrams of European. I do a little class on that one. I have fun with doing that one. So I go up here. I want injector number 5. Get used to using this because a lot of the car companies, even General Motors, is starting to put letters and numbers out there for components. They are not giving you what it is. So N83 is my fuel injector. So I've got it up here. I've got my circuit, OEM. So I have GN and G. GN and G is green with a yellow tracer. All right. That's my ground side. Notice they're all connected together. All right. or is that my feed side? They got a really weird way they do things here. The other one is going to be Schwartz or Rowe, which is black and red tracer. So what I'm going to do up here, I'm going to go to my injector. I recommend you use the back probe pins like this to do an injector. Don't be putting a T in there if there's a chance you're going to short it out to ground. I have done that over a period of time, took a few computers out. So I duty cycle both wires. I get 4.95 volts. Well, German engineering decides that any solenoid, before you fire it up, they're going to put 5 volts across to verify it. If it was shorted, the voltage would be shorted. So they know that. So I got 4.95 volts, all right, on both wires. If I have a domestic car, I would have battery voltage on both wires. Fired up, and I'm on one wire and I got 13.75, and the other wire I've got 13.74 and moving. Well, I know the one on the left is my feed wire. The one on my right is my wire that's being pulsed to ground to activate the injector. So if you have a system, this is one thing I tell everybody to do, flip it over to Hertz. If you flip it over to Hertz, you know, and you get 0, that means that voltage is steady. It is not changing. It means it's not being pulsed. That's a feed wire. That's good. If I flip it over to Hertz on the other wire, I've got 6.02. That's my Hertz. Notice I have a trigger at 0. Excuse me, trigger is positive there. On a Hertz reading, it doesn't make any difference. All right. So I'm just showing you there's a trigger. To change the trigger, there's a plus or minus trigger here. And I'm on the 88. On the 87, it doesn't say plus or minus trigger. You just hit that button. That's also my peak min max button. So I've got this one up here, no problem. So I have Hertz reading. The next thing I'm going to do on this one, if I was on 87, this is where I'd end up. I'm on trigger again. I'm going to show you the trigger one more time. Trigger's on negative. I got 2.5 duty cycle percentage. All right. Now, if that's duty cycle percentage up there, if you have no way of changing the trigger, you take 2.5 from 100, or you take whatever you get reading, you take it from 100. Let's say it's 85.5, or on this one, it would be 87.5. I would subtract that from the number, and I know my duty cycle would be 2.5 if I have not got the ability to set a negative trigger. Anything that's pulsed to ground, I want to set a negative trigger. On an 88, it will give me millisecond duty cycle or millisecond pulse width up there. So I got 3.5 milliseconds pulse width. Notice I'm in manual. Notice I'm at negative trigger. So that tells me that I have 3.5 milliseconds. That should match whatever my scan tool says. So that tells me my pulse width. And a lot of guys will stop right here. Don't. Next thing to do is put your meter in min max and then put it in peak min max. Hit the min max button first, then hit the peak min max button, which looks like, you know, a signal for a speaker or something. And then duty cycle to, and then push the button up there, the min max button, you get them up to 69.17 volts. That's the maximum voltage of the spike as the injector's turned off. All right. If I'm on a Chrysler product, it would be 36, 37 volts. It's not going, they chop it or block it at that particular point. German Motors might read over 100 volts. So you know right now the injector has opened and it has closed. And there's your spike you're going to see in voltage. I also can go over here and hit minimum. Now, if I hit minimum, notice I'm in manual, by the way, at 60 volts up there. And if I'm in minimum, I want somewhere under about 0.2 volts. All right, that's my ground. Some people say 0.3, 0.4, but this one 0.16 volts on the ground wire. That means I've got a good ground on this injector. If that was not there, I could have a bad ground on my injector itself, or if that number is jumping all over the place, I've got an issue with my ground. Okay, I'm moving quickly, guys. 3-wire sensors. This is what to look at. We have a 5-volt reference sensor signal, and we have a powertrain control module ground, PCM ground. So I've got this up here. What would be the voltage at A, B, and C? This is German Motors. They do some really weird stuff on there. A is up there. That's 50 millivolts. I need to be under 50 millivolts because that's my ground. Now, if you notice something interesting, it says low reference. That means if it's low reference, it's using the computer itself, the case. It's a case grounded circuit. It's going to ground it to the case on this one. If I go up on this one, you will notice that B is my sensor signal and C is my 5-volt reference. 48C1, that C is reference going in my map sensor. If we look at B, that comes down to what? 32C2. So we're looking at the circuit. It's not sharing anything with this circuit, but that's an interesting way of looking at things up here. Now, German Motors up here, if I'm on B, is 4.6 to 4.8 volts, key on, engine off. That's their specs for the map sensor. Not everybody follows that spec. And C, 4.9 to 5.1. So A and C are pretty much the same. B might be different for the car you're working on. If I go to my next one up here, this happens to be a Chrysler signal. So if you look at sensor ground, pin number 22, C2. And if you notice it goes up here and we're dark blue with dark, what? DG up there. So we're looking at the process. I am sharing the ground on that sensor. So I'm sharing the ground on the map, inlet air temp sensor, and the coolant sensor. So if I have a ground issue, it will affect the readings on 3 sensors. So keep that in mind. If the ground issue is there, it would usually make sure the voltage will remain higher because you can't go to ground with it, so it remains higher and it elevates. So I've had times where I've had map sensors read, instead of what I'm going to show you in a second, they're going to read slightly higher and indicate a ground. You would actually clean the grounds and normally fix it. So I have 4.91 volts. Again, 4.9 to 5.1, I'm okay. 4.3. Notice on this sensor, it's a different range the way they work. I got 4.3 volts, all right? 4.3 volts up there is the range for the atmosphere that I'm at. Barometric pressure there is 29.2 at that particular day. And there's my ground. And it's what? Is it under 50 millivolts? Yes, it's a little high. It's at 43, but it's still under 50, so I don't have a problem. At idle, I should read 0.8 to 1.5. Some people say 1.6. I'm reading 1.554. That good map sensor at idle. Now, we're going to flip over to the map sensor, which we have a lot of trouble over a period of time. And these are the specs you're going to look at. We're going to look at an Audi, 1 volt to 1.5. Key on, engine off. All the German cars that are analog sensors, HMF5, HMF4, mass airflow sensor in the PurePoint, whatever it is. I think Pureberg, excuse me. And they should read 1 volts, key on, engine off. So you can double check the system. If no airflow through, 1 volt. So what I did was up here, I came over here and I want to look at my mass airflow sensor, and they call it mass airflow sensor. It's on the air cleaner assembly. I got a yellow, a black and blue, and a green. I'm reading 1.56 volts at idle. Now, if I was reading 2 volts, or if I was reading under that, that would indicate I have a bad mass airflow sensor or bad wiring to the mass airflow sensor. I'd go back and check my readings. So this one's reading okay. I could have done this one also by going up the key on, engine off, and doing the voltage drop on this one, because it's pretty far away from the computer. Snap throttle, I read 4.23 volts. What am I using again? I'm using MinMax again, all right? So I'm reading 4.23 volts. It's working good, okay? Let's go over to the next one up here. Controller area network, and it's asleep. I'm doing pins number 14. If everything's asleep, on most cars we have 2 120 ohm resistors in parallel. When they're in parallel, I should read 60 ohms. I'm reading 59.4. This happens to be a Chrysler product, and they put out a 60 ohm resistor by itself. We'll keep that in mind. So I'm reading properly. The next thing I might want to do is read the voltage. So I'm going to pin number 6 to pin number 5, or I could do pin number 4, whatever. It doesn't make a difference. You need a breakout box, by the way. So I should have 2.5 volts. That's at rest. The computer's not working. It's not doing anything. If I had higher than that, it would indicate I'm shorting to power. If I had less than that, I would be shorted to ground. So keep that in mind if you look at the information. Again, pin 14. 6 and 14 is your CAN pins. I'm reading about the same voltage, the same issues that we need to look at. If it's reading high, I'm shorted to voltage. If it's reading low, I'm shorted to ground. And I'm just going to bring this last thing up there. Well, I got a few seconds here. I want to do the series circuit for you and look at it real carefully. I'm putting a problem in this circuit, and I'm going to use my voltmeter. This kicks everybody's butt, all right? So notice I got 12.69 volts. Before my switch, 12.69. After my switch, 12.69. Before my bulbs, the bulbs aren't working. All right. So that tells me I have an open circuit. Now, if I would have gone up there and put it a process, the bulb's not working. I would only had a voltage after over that would have been a ground. So anytime you have voltage that is not being used up, this circuit is open. Just like that battery we were talking about before. That's open circuit voltage. Nothing's being used. So again, this is an open circuit. That's why you differentiate between the two. I should have checked voltage again, showing you that the voltage dropped from 12.69. All right. Gary, you got questions for me?
Yeah, we got some, Jim. Hey, everybody. If you have any other questions, toss them into the questions pane. Jim, what do you think about using wire piercing probes?
I don't like it. Main reason is over a period of time, I've gotten my butt kicked a few times. If you're going to do that, make sure you use either nail polish or silicone on it. Wire piercing probes is going to open you up for an issue where you're going to have what they call corrosion can build up inside the wiring area. I would recommend you go and use back probe pins instead. And just, back probe pins, and go online, they'll show you that you should actually push the back probe pins and does better. Do I have the piercing probes? Yes, I do. Do I use them anymore? No, I don't.
All right, good stuff.
You're better off not using it. You'll sometimes, by the way, if you back probe a wire, which I have done in the past and forgot to seal it back up, the moisture got in and corroded the wire up itself. So I end up having to replace the wire over a period of time. When you used to work on it. Yeah, you don't want to do that.
No. Am I going to damage anything if I accidentally connect leads backwards on a variable reluctance sensor?
No, you're not. That's what everybody's been asking me. No, you're not. But the reason I bring it up, get used to hooking your leads up correctly. And that way you're not going to get the negative reading you would do on a circuit. It's just, you're not going to hurt anything doing it, but you do need to hook up to both wires on a magnetic sensor circuit. You're not going to hurt anything, and it's not going to cause you that much of a problem. I just tell you that if you get used to doing it correctly, you'll remember. And what you do when you hook up any other circuit, always remember, hook the red lead the most positive side of the circuit, black lead the most negative side of the circuit. You will never get those negative numbers, and it'll make your job a lot easier over a period of time.
Good stuff. That looks like it for questions, Jim. We'll cut these folks loose.
Hopefully, guys, you enjoyed it. I appreciate it very much, you guys showing up. And I'll leave it back to Gary. Do your announcement there.
Thanks, Jim. If any of you have any further questions after the class ends, send an email to WTI@worldpac.com. Try to include class number LTT408 in the subject line. And last thing, please take a couple minutes to fill out the survey that's going to pop up on your screen when we shut this down. We pay a lot of attention to the surveys. We're scheduling for 2024 right now, so class requests will really help us to make sure that we're giving you the classes you need. And I'm also going to ask you, when you do the survey, in the comments, please tell us if you think we should do this class in a 4-hour class with a workbook. Any final thoughts, Jim?
That's all I do, guys. Hey, I appreciate you showing up. I appreciate you doing it. Hey, guys, learn to use your meter. Go out and read the manual. You're going to find some really interesting things you can do with your digital voltometer that you didn't even know. By the way, I've read the manuals lately. and reread them. There's some stuff I didn't know was even there. So,
Yeah, good stuff.
all right, guys.
See you all next time.
Thank you very much.